Welcome to Answer Everywhere. This is an improvised live show where sometimes our microphones work and sometimes they do not. But this on this show, every week we take a look at a source code repository and try to dig around. I apologize for those who are I had to fiddle with my microphone. I have no idea what's going on. That's not a thing that I've encountered before. But I don't have a ton of time today, and this is not my usual streaming time, but I'm trying to switch things up a little bit. And I thought I would look at the i3 tiling window manager, which seems to be the go-to tiling window manager for people who are into such things. And my understanding is that Sway is related to i3 and is kind of like the Wayland version of i3. And that may be the cooler thing at this point. But since we've looked at Xorg and we haven't looked at Wayland yet, I thought it would be good to check out i3 in particular, and that will give us kind of a tie-in with what we've seen before. And I have GitHub pulled up, but I've basically abandoned GitHub other than to check the languages. Mostly C, as opposed to, for example, C++, some Perl, which may tell us a little bit about when this project was started, because I don't see a lot of new projects using Perl. Okay, so Karin is saying they used to use i3. I've personally never used, I think I've used Awesome Window Manager, which is either tiling or has some tiling tendencies, but that's the only one I've used. I obviously use Emacs, which tiles all of my Emacs windows. But for, my personal preference is just to have kind of one thing at a time. And when I've tried to use a lot of workspaces, I found that there's like a combinatorial explosion where I'm trying to figure out all the different windows that need to go on to each workspace. And so it's been easier for me to just have like a floating window manager. But the people who use i3, I think they make a good case for having like a neat, tidy set of like pre-configured workspaces that you can flip between. And from what I've seen so far in the code, it seems like a relatively bounded amount of complexity. So let's dig in and see what we see. So I think I'm not in the root technically. Yeah, I'm in the root. Okay, so in the root we have source. Meson's going to be build. Lib-i3 is probably some library support, or rather, it's going to be some amount of functionality that is, I guess, most likely exposed to other projects potentially. So I think that is going to be important. I guess since I'm in Emacs, I'll go ahead and mark it. We'll mark source. And then we have a bunch of these little directories like i3 message, i3 nagbar. That's different from navbar, which is what I originally read it as. Maybe nagbar is for like notifications that nag you. And then input and dump log, I'm going to ignore. Input should mostly be functionality that I would guess is mostly shared with other, things like keyboard and stuff. Not particularly i3 particular. Bar might be important. Config wizard, I'll go ahead and ignore. And then I imagine Etsy is going to be mainly configuration that either wants to live in /Etsy or maybe in the home directory. So once I configure it, I'll be happy, but I'm always changing due to the placebo effect. Yeah, I'm definitely one of the people who fiddles with everything. On YouTube, I think the view that people have of me is this kind of like stock VM, and that's pretty close to where I am now. But I've explored a lot of the various approaches, and the stock VM is much more bare bones than my regular machine. All right, so here's source. I have a feeling source is going to be where I want to be, but I'm going to open up lib. See, here's where I could use some sort of tiling window manager, is to have a place where the chat lives. And I'm sure there are other solutions to this problem. All right. So what did I say? Lib3. So lib3 and source both have just a relatively small number of C files. On the right, we have lib-i3. which has things like boolster, which is maybe some sort of conversions between booleans and strings, draw utility, fake configure notify, font stuff, format placeholders. A lot of this stuff looks like kind of utility C things, just from the name, like boolster, format placeholders, get exe path kind of seems like a utility. So I think I'm not going to go too far into them, but I do want to check this directory to see if there's anything that looks super interesting. Screenshot wallpaper has its own thing in string. I guess just out of sheer curiosity, what's in string? We have an i3 string, which is a UTF-8, I guess like a car star, which is essentially a string, and some XCB. Is that I forget what XCB is. Maybe we should look this up. And then the number of glyphs, the number of bytes, and some Pango stuff. I don't really recall what Pango is. That's something desktop E, I think. So let's look up XCB and let's look up Pango. X control buffer. X protocol C language binding. Okay, so XCB is a C binding for X, which we, since we saw X, we can imagine what its C bindings look like. And then Pango is a library for laying out and rendering of text with an emphasis on internationalization. Okay, so laying out text, and they support hopefully many languages. Okay, so on the left here we have source, which I'm going to guess is where all of the cool stuff happens. Drag should probably be drag and drop. MH, no idea. I guess we'll take a look at it. Gaps, I think, is for, I believe there's a notion of i3 with gaps, as in whether your screen has blank space or not. Is that right? Let's see if you can find any images. I see lots of images that appear to be i3, but nothing really about gaps. Gaps are the namesake feature of i3 gaps and add spacing between windows and containers. Here's a user guide. We have inner gaps and outer gaps. You can configure two kinds of gaps. So that the space between adjacent windows are gaps. So that's one thing. And then I guess outer gaps are like a framing around the screen. And this is familiar to anyone who's ever like formatted a document. These are basically margins. Okay, so that's gaps. Should we look at gaps? I'm not sure. IPC is probably important, although I'm not sure how essential that is to thinking about what i3 is about. Move, I'm going to guess, is important. I don't know what match is. That might be some sort of dispatch where it's trying to figure out which window is going on. Render and resize. Render definitely. Resize maybe. Restore layout is probably important. stdaemon. I'm not sure, but I guess I'll take a look at it. Startup. Look at tiling, drag, and tree. Tree is probably pretty fundamental. And then window and workspace. And then these X things I'm going to guess are bindings. So cursor is obviously cursor. XCB is the binding thing. X is maybe some sort of X entry point. Xenorama I'm familiar with from the old days, but I don't remember what it is. It's an extension to the X window system that enables X applications and window managers to use two or more physical displays as one large virtual display. Okay, so if you have multiple displays, you can, I guess, yeah, I think that's the normal way to use them, right? So I have two monitors, and I can go between them. I guess that's probably what it means by unified. But I don't think I could have a screen that spans both monitors. I think it has to be in one place or another, and I'm not sure if that's allowed by Xenorama. All right, I guess we'll peek into Xenorama just to see what's going on. Only 127 lines. We have init. Okay, so I'm going to guess that's not so important. Let's peek at x.c. This is much larger, so I guess we'll look at this as well. Should we start at main? There's a lot of main fans out there. So let's look at main. And usually main, the cool things are at the bottom. This seems to be maybe possibly the long main. Yeah. Okay, so 279, we start int main. And then before that, we have some things. I'm sure there's a better way to do this, but let's see if I can just list some of the functions here. We have just this like got event thing, so we can, we'll need to get events from X. This is some utility method, presumably, preparing the bindings, and then set X11 binding stuff, exiting IC, handle core signal, handle term signal. These I consider to be kind of like setup and utility-ish methods. Let's just jump to main, where I think is where the action is. And we have this comment: keep a symbol pointing to the i3 version string so that we have it in GDB backtraces. Okay, that sounds useful. So we have a bunch of config stuff, path layout, a big struct of options, including things like auto start. I'm not sure what is auto starting. Maybe whether to auto start particular programs or clusters of programs. I'm not sure what in i3 world. Let's say if I want to have a workspace with like my browser and a terminal, or like 7 terminals or whatever. I'm not sure what they call that kind of cluster of applications. And we have 3 versions of more version. I'm not sure why. And those sorts of things. Okay. So then we set locale, do disable output bufferings to make redirects in .x session actually useful for debugging. Okay. Then we initialize, this seems to be, SRAN I think is initializing a random number generator based on the time, which is not super secure, but I don't think that you really need it. What are we even using SRAN for? Randar is not random, right? That's the X rotation thing. All right. So then we initialize logging. And then we parse options. And this is all kind of like standard parsey stuff, it looks like. If the user passes more arguments, we act like i3 message would. Just send the arguments as an IPC message to i3. This allows for nice semantic commands such as i3 border none. Okay, so if you, I guess you can just keep passing command line arguments, and then ultimately they go to some, whatever the IPC server is doing. I'm guessing, so X, I guess, has its own kind of IPC server, or I think, at least in some of the talks, that they called it RPC. I'm not sure. I don't remember exactly what they called it in the code. But I think that this is an i3 specific IPC server that maybe talks to X, and then in the future would talk to Wayland or whatever. And they're setting up, I guess, IPC stuff here. So we get the payload, and we do some stuff with sockets. And I'm otherwise mostly going to ignore it. Then there's some debug stuff. Then we call XCB connect with the connection screen. Let's see, where did the connection screen come from? You should have tags. Okay, so connection screen starts at 0. And then we just, like, it's not used, I guess, before this. And then we check if there's an error, like whether we can't open the display. I don't know what this is, something with SN. And then we get to what appears to be the main loop. And we're using libev, the libev event loop, which is that the same event loop that was used by I feel like we've run into libev before. I'm not sure if it was in Node or something else. I guess let's look this up just for continuity here. I feel like that was like libuv. Maybe it's not going to tell. Libuv is Node. I don't know the difference between libev and libuv. They seem to both be event loop libraries. And I think maybe we discussed this on that show. So libev, this seems to be some Python stuff, but it's a venerable event loop that has been the default in Gevent since back in 2011. The libuv is an event loop library developed since 2011 for the use of Node. Okay. It was originally a wrapper around libev on non-Windows. Okay, I didn't appreciate that when I was looking at the Node code that libuv was written for Node. But that sounds reasonable. And so I guess it used to be a libev wrapper, and then maybe it's gotten new functionality since then. Okay. So I'm going to think of libev as more or less like libuv. At any rate, we have this comment: initialize the libev event loop. This needs to be done before loading the config file, because the parser will install an ev child watcher for the nag bar when config errors are found. I guess that's so that you can be nagged about config errors. Main loop must be ev's default loop, because at the moment of writing, only the default loop can handle ev child events and reap zombies. The start application routine relies on that too. Okay. So the main loop is ev's default loop because of the zombie issue, which is appropriate for the Halloween time. We check that the main loop is not null, and then we get the screen from the connection using a call to, what I believe is a call to X, and we set the root to the root screens, whatever we get back essentially from root screen. Then we prefetch X11 extensions that we are interested in. This doesn't seem to be, just any extensions you're interested in. It seems to be particular keyboards and shapes. And then big requests used by libxcb internally. I guess big requests is maybe an extension, possibly like larger RPC messages. I'm not sure what big means. Maybe the RPC doesn't contain all of the information. Maybe you have to like look in a memory buffer or something. Okay. At any rate, after doing that, we prepare to get the current timestamp as recommended by ICCCM. Okay, that's fine. Place requests for the atoms we need as soon as possible. And then I'm not sure what an atom is, but we get some atoms. Set the root depth. We get the color map. And get the visual type. Make sure it's not null. Do some cookie stuff. This kind of seems like X11, just not necessarily quite boilerplate, but probably relatively standard X11 library stuff. And then we init DPI and log some stuff. We get a geometry cookie. I'm not sure why this is a cookie, but at any rate, I want to see why this is called a cookie. Get geometry. The Arch man pages, I guess, have some information. What about XCV cookie? No? What about ChatGPT? Tell me about cookies in the XCV library. Oops, I misspelled library. But apparently, they refer to a mechanism using the X Windows system to synchronize and track requests and replies between the X client application and the X server. Okay, so I guess that's similar to a cookie in browsing. XCB is a low-level replacement for the xlib library designed to be more efficient and to provide a better interface. A cookie is a structure that represents a pending request made by a client to the X server. It serves as a way to track asynchronous requests and their responses. Okay, so you generate a request, and it gives you back a cookie. Instead of blocking and waiting for a reply, XCB returns its cookie. Okay, it contains information about the request, including its type and the sequence number. And then we can continue processing. And then once the X server has processed the request, it sends back a reply to the client. To retrieve the response to the request, the client uses the cookie it received when it initially made the request. The cookie contains reference to the response data. Okay. Hello, Doraj. They say, I finally made it live. Excited that it's i3 too. Oh, cool. Yeah, you moved to Sway. Yeah, I hear Sway is the place to be. If we had looked at Wayland already, I probably would be looking at Sway. But since we haven't done that, we're looking at i3. Okay, so this is some kind of weird, mildly awkward way to do asynchronous requests. I'm not quite sure I understand how main is going to know that the response is done and that it's ready to redeem the cookie. Maybe, I guess it probably gets some sort of notification. Get the property notify event we caused above. So we call XCB flush on the connection, which presumably flushes some pending stuff from some sort of queue. I guess maybe events. And we have this generic event, and we say that we're waiting for property notify. Okay, so we just wait for the event. And we pass in the connection to wait for the event. And I guess that will give us all events, and we check whether that event is in particular this XCB property notify. And if it is, we look at the timestamp and free the event and break. And if it's not, we just free the event. Does that mean just we ignore it? All right, so we just recorded the timestamp. I don't think we've done anything with the cookie. See if I can do an occur of gcookie. So here's where gcookie, I just am very curious about these cookies. Here's where gcookie is used. We call get geometry apply, but this doesn't seem to be triggered by any particular event. It's just a thing we eventually do. Okay. Here are we? Here. All right. Then some more stuff about atoms, which I still don't know what they are. We load a configuration from the configuration path, I guess. And we check the IPC socket path. And I guess make sure it's not null. Or wait. So if it is null, then I guess we call get process. We set it. If it's null, we set it. And then we create the socket, given the path and given the config socket path and I guess this is maybe something that's modified. I'm not sure. But we're passing it the current socket path. The fact that it's not -1. Check if we, I guess, need to enforce Xenorama. And then we acquire the window manager SN selection. And, oh, I guess SN is probably screen. We call it atom name by screen. I want to know what an atom is. What is an atom in the same library? An atom is a fundamental concept. Okay, it's not specific to the XCB library. It's a core concept in X11. All right. Here are the key points about atoms. They have unique identifiers. They have property names. Standard atoms. X11 defines standard atoms for common properties, such as the window manager name for window titles and icon name for icon names. Okay, and you can create custom ones. They have efficient string storage. All right, did I miss some important information? It's like basically just a thing. It's like a thing that X11, it's like an object in the language of X11, I guess, is how I'll think about it. So not necessarily like a window. It seems like a thing that can have a title, but possibly a window is an atom, and then there are other things that are atoms. Okay. We have some atom. Okay, so we're doing more communication. We're just creating a reply object to stuff to reply into, and we do more IPC with X, and we free the atom name. It's too bad that C makes you call things like free manually. I wonder if some of this stuff seems like maybe it would be nicer to eventually rewrite it in C++. And maybe Sway is. Actually, let's look that up. Let's see if do we get to it's in C. Okay. I honestly don't know enough about like really performance things to know whether there's still a place where you like really need to use C for a full project. Maybe it's required, or maybe it's because the X stuff is in C as opposed to C++. All right, so we check if the selection is already owned. We become the selection owner and call create window. I'm not sure exactly which window we're creating, but we're going to pass it the connection, which is as expected. We're going to pass it the root depth, the window ID, the parent, the geometry, and the border width. And then we call change property with some string, and the string says that we're an i3 window manager screen is I guess how we're probably supposed to think of this. And we call set selection owner with the last timestamp. And I think last timestamp is the thing that we populated while we were looking for events. So I guess that's saying that we own that screen. And we check the reply and make sure it's not a, I guess, XCB none reply. And we sleep for 0.1 seconds and wait for a maximum of 15 seconds. And this is, I guess, we have this get geometry reply, and we're going to be in this do loop, do while the geometry reply is none. We're going to free the geometry reply, sleep for 0.1 seconds, decrement the check rounds. I don't think we seem to be doing any back off, which I guess we probably don't really need to do for an X server. And then we're going to try to get the reply given the connection. And the second thing we're passing in is the same, is also a call to XCB get geometry. Oh, no. Okay, so I think this is like we're initializing the reply from the call to XCB get geometry. And then we free the selection reply. What I don't understand is why this isn't a cookie thing. It seems like cookies were designed so that we didn't have to like wait, but maybe there's no choice but to wait, or maybe this thing doesn't support a cookie. But I thought there was a geometry cookie. There is this get geometry cookie, but I don't think we've used it. Okay. We have a cookie appears in this macro. All right. Whatever. There's you sleep. Okay. So if we're down here, we announce that we are the new owner. This is like I'm the captain now, I guess. And then we have this union of client message events and a storage of 32 car, and I guess a car array. Every X11 event is 32 bytes long. Therefore, XCB will copy 32 bytes. In order to properly initialize these bytes, we allocate 32 bytes, even though we only need less for an XCB client message event T. Okay. And then we, I guess, set memory to 0 and set up some event stuff. And eventually we call XCB send event. What is the event? I think it's this XCB event mask structure notify. I'm not sure what that's doing. Here we get some more cookie stuff, a void cookie. And we call change window attributes checked. And do some error handling. Here we get the geometry apply, and I guess finally passing the G cookie. I'm not sure why we didn't pass it in before. And we check that it's not null. And then we load cursors. We set a cursor for the root window. Otherwise, the root window will show no cursor until the first client is launched. Okay. And then we do some query stuff. And we use some extensions. And there's some masking stuff. I'm going to kind of rush a little bit through here now that we have kind of like a flavor of what's going on. We restore the connection. We initialize property handlers. EWMH, I still don't know what it is, but we saw this in that file, so I guess we'll take a look at it. But it will set up hints. Numlock stuff, I guess, whether we're using numlock. Try to load the key map, possibly fail. Translate key sims and grab all keys. We set needs tree init to true, so I guess we know that we need to initialize the tree. We'll look in the layout path and I guess try to restore the tree. So I think tree .c or tree restore.c is its own file, so we'll look at that. And anything else? We need to force disabling outputs, which have been loaded from the layout file but are no longer active. Okay, so we'll kind of ignore this. And there's lots more X stuff. So some of this might be super interesting, but since I don't have a ton of time, let's go to some of the other files now that we've kind of seen some of them in action. X.c, I'm going to guess, is mainly utilities. Interface to X11 transfers our in-memory state to X11. C also render.c, basically a big state machine. Cool. Here's some of the state stuff. Connection state describes the X11 state we may modify. Map state, position, window stack. There is one entry per container. What is a container? I'm not sure. The state represents the current situation as X11 sees it, with the exception of the order and the state head circle EQ, which represents the order that will be pushed to X. Okay. So, the con. Is con connection? I'm not sure. Can I go here? Commands type def struct con. The forward declaration. I'm not really sure what a con is, but possibly connection. All right, so this is communication with X. What I want to see is, for one, let's find out what EWMH is. An improved dynamic tiling window. Oh, that's the copyright statement. Get or set certain EWMH properties. So this must be a general thing. Let's try just looking it up. Extended window manager hints. It's an X standard for communication between window managers and applications. And it builds on the functionalities of the ICCM. Okay, so this is something I'm going to consider an implementation detail, just in the interest of moving along. Let's look at IPC just to see if there's anything that sticks out here. You've got sockets, tail Q. Not sure, is Q for like a Q, the Q data structure? I think that's a thing. Tail Q. Is a thing. These macros define and operate on doubly linked tail queues. Okay, I don't really remember what a tail queue is, but maybe Wikipedia knows. Is it the same as a double-ended queue? Elements can be added or removed from either the front or the back. Okay, so I guess it's a double-sided queue. And we have push pending, which tries to write the contents of the pending buffer to the client subscription socket. We'll set or reset or clear the timeout. Okay, so this is IPC stuff. Send client message, free IPC client. Okay, this seems to be legitimately just kind of like utility routines for putting together the IPC stuff all in the same place in a nice way to use. Okay, so is match interesting? A match is a data structure which acts like a mask or expression to match certain windows or not. For example, when using commands, you can specify a command like this: title equals star Firefox star kill. The title member of the match data structure will then be filled, and i3 will check each window using matches window to find the windows affected by this command. Okay, so I'm going to guess that this is either just standard string matching or regular expression matching, and they've got some sort of data structure for what a match is. And we've seen enough of that sort of thing, I think, before in other repos that maybe I'm just going to ignore it for now. This is moving containers into some direction. Let's find out what an i3 container is. Every container has an orientation, it says. A split container. But what is a container? Do we get a first occurrence of the word container? Whoops. It's some sort of container of things, but I just don't know whether it's a container of is it a container of Windows? Is it like the same as a can one workspace have multiple containers? Confused a bit about Windows versus containers. I don't know. Let's try the chat GPT. In i3 window manager, what is a container? It's a fundamental concept. Seems to be like a stock reply that ChatGPT has. Represents a grouping or layout area for windows. They're used to organize window managers within the i3 window manager, blah, blah, blah. So they have a hierarchical structure. They organize windows into a hierarchical tree structure. Yeah, we've seen the tree a little bit. We'll look more at tree. Each node in this tree can either be a leaf containing a single window or a container containing other nodes, which can then be windows or nested containers. Okay. Workspace splitting. Containers are used to split workspaces into different regions. Okay, so when you have a workspace, the different regions are containers. For example, you can have a horizontal or vertical container. Okay, so like an Emacs, I guess. I'm going to assume that this is what it is. So like if I have maybe the left container and the right container, and the right container has two windows and the left container has one, that's how I will think about containers. And no one can stop me. Okay, so move is for moving containers into some direction. I don't know if this means like expanding them, but we'll see. So it returns the lowest container in the tree that has both A and B as descendants. This is kind of nice. This is super short. We have two containers, pointers A and B. We create this parent A and set it to A. And while parent A, which should exist as long as A was non-null, we'll set parent B to B. And while parent B, we'll set parent A. We'll check if parent A and parent B are equal, in which case we return parent A. We set parent B to parent B parent. And we set parent A to parent A parent. And then we assert false. Returns the lowest container in the tree that has both A and B. Oh, okay. So this is the lowest container that has both A and B as descendants. So this is like the most recent common ancestor of B of A and B, I guess, right? This is the sort of thing that you do a lot of interviews, you'll see like 600 implementations of something like this. Okay. So we also have this thing that returns the direct ancestor. Returns the direct child of ancestor that contains con. So you pass in con, and it's going to give you the direct child of ancestor. Oh, okay. So you pass in ancestor and con, and I'm not sure what direct child means. I'm sure there's a sensible way to parse this, but maybe my brain's not working. At any rate, it's going to give you some sort of, I guess, descendant of ancestor that contains Khan. And I'm not sure what happens if, like, is it the first child that has Khan as a descendant? I'm not sure. Okay, returns true if the given container is the focus descendant of ancestor. Okay, so this is all ancestry stuff, at least so far. This is all kind of stuff that you could program for the most part as tree routines, working through like a data structures textbook. Maybe we probably have a lot of this sort of stuff. We also have things like attach to workspace, which detaches Khan from its parent and puts it in the given workspace. Position is determined by the direction of movement into the workspace container. Direction of movement into the, I'm not sure where it gets the direction. But I guess that's probably there to be kind of, to feel natural. And so this is a way of attaching, I guess, containers to different workspaces. So that's cool. As I mentioned at the top, I don't have a lot of time, so I'm going to not stop and smell the roses as much as I ordinarily might. Hey, why can't I undo this? Oh, there we go. But we should look at tree before, just in case I run out of time. Okay, so the tree should be the main tree, right? So everything's contained in this tree, and we saw that, I guess, containers. If you're a leaf in the tree, then you are a window, I think is what ChatGPT said. But otherwise, you're like a container, and I guess you like root another tree. And so this should be hopefully a pretty straightforward implementation of a tree. Tree.c, everything that primarily modifies the layout tree data structure. Okay, so we have this create i3 thing with many underscores. Create the pseudo output i3. I'm not really sure what this is doing or why there are so many underscores. Output independent workspaces such as underscore i3 scratch will live there. And we have this connect new, I guess, and you pass in the root, and you're going to freeze some stuff and set names and hook up outputs. It looks like fixed percent. I'm not sure what that means. Maybe that picks up a fixed percentage of the screen or the container. We set name and we set the width and height to 1280 by 1024. For retaining the correct position size of a scratchpad window, the dimensions of the real outputs will be multiples of the i3 pseudo output. Huh. So it seems like this by pseudo output, maybe it means that it has like a model, and that model has like a specific geometry, and then we get other screen sizes by using multiples of this geometry. Is that what it's saying? I'm not sure. And then once we have the geometry, we add a content container, and we set the name, and we have a Scratch workspace. And I'm not really sure what the Scratch workspace is, but maybe we can find out. i3 Scratchpad. I'm not sure if the Scratchpad is an internal thing that they use as a model. What is Scratchpad? There are two commands to use any existing window as Scratchpad window. Move Scratchpad will move the window to the Scratchpad workspace. This will make it invisible until you show it again. There is no way to open that workspace. Okay, so I guess Scratchpad is maybe like a you like hide it under your desk until you're ready to look at it again or something. Tree restore is presumably going to restore the tree. Tree init initializes the tree by creating the root node. We just pass it a geometry reply object, and it ultimately calls create i3. And we set stuff here. We set some geometry by calling croot rectangle. So croot comes from con new, and I don't see a real tree data structure yet, but maybe we'll find it. Open con opens an empty container in the current container. So we're already in a container, and we're going to create a new one. So I guess con is probably container, right? So if con is null, then every focusable call has con as a parent. Okay, then we do a bunch of stuff, but what if con is non-null? I guess non-null, we're down here. Create the container and attach it to its parent. We just call, I guess, con new must be new container with this window. And maybe this is the parent. And we set the layout to L splith. And we recalculate the child percent for each child. Okay. So I guess fixed percent, I said maybe that's about having a fixed percentage of the screen, but I don't think that's the case now. I think that it's about walking the tree and fixing up all the percentages. So we saw in stuff like Flutter, we had this idea that like, I guess children would tell their parents, I think, what area to render. And as you walk the tree, you would use that information to render it. And here, we basically have to do another thing. A similar thing. We have some tree, and the tree has constraints. And as we're adding like children containers, we should expect the containers that are already on screen to move out of the way. So, for example, just an Emacs, like as I add more windows, it's the existing windows are getting smaller, and I think that's the sort of thing that fixed percent is doing. I'm not sure what lsplith is. These are different container layouts. Default, stacked, tabbed, dock area, output, split vertical, and split horizontal. So split vertical should be basically like that. Split horizontal should be basically like that. I'm not sure what the other ones are, but I'm sure that they're relatively straightforward. Con new is a wrapper for con new skeleton. And this is going to, so the first argument is the parent, and the second argument is a window. And con new skeleton, which is also appropriate for Halloween, create a new container and attach it to the given parent. Okay. And then we have this tail queue insert thing. And I'm mostly going to ignore it. We've got a floating head, which is also appropriate for Halloween, as is swallowing your head. Okay. So, and then con fixed parent, I'd like to just verify that this is going to walk the tree and update things. Updates the percent attribute of the children of the given container. This function needs to be called when a window is added or removed from the container. So we should be able to see, so let's say you have a container with just one window, and then you add another, then the current window should probably become half of its size. I'm not sure if we'll see how that will work, but we have this tail queue thing, and for each of them, if I guess child percent must be the percent that the child takes up. Let's see if we can verify that this in some way. Well, it doesn't say, but so if it's more than 0, then we add child percent to the total, and we increase the number of children with percent. If there are children without a percentage set a value that will make the children proportional to all others. Okay, so proportional to all others, I guess. I assume it means like mostly the same size, but maybe they're just proportional. So if children with percent is not children, I guess I think this means that there's at least one child that doesn't have a percent, then we're going to iterate over them. If their percent is less than or equal to 0, then we set, okay, if it's 0, then we set the percent to 1, I guess. I guess that's what it means by proportional. And then we increment the total by that, I guess, that amount. Otherwise, we set the total to be the total divided by children with percent. Okay, and all right, so that's fixed percent. There's probably more interesting stuff there as well. Tree close internal, and then we can close the container and whatnot. Okay, so that's cool. I don't know what tiling drag is. Reposition tiled windows by dragging. So this is like drag and drop stuff. This is just, all right. So it's about 419 lines. I have to go in about 5 minutes. So I'll try to maximize the most interesting stuff I can see in my time here. So this is drag and drop. This is potentially interesting from the perspective of learning about drag and drop. But I'm not positive that it's going to tell me a whole lot about i3 in particular. So I guess I'll ignore it. SD Daemon is probably not so important. Leonard Pottering. I've heard this name before. Is that the person, the system D person? Pulse audio in system D. Okay. I guess SD is probably system D. I'll just assume that's system D. Restored layout. This should presumably be for restoring a layout that's been saved. Restore layout, handle event, restore XCB, prepare. Yeah, I'm not sure. Window size has changed. Update the height and width, then recreate the back buffer pix map in the accompanying graphics context for some immediate re-rendering. Okay, that's probably fine. Render.c should be, we saw a comment in the code that suggested that this file contains more communication stuff with X11. Render the deco height. Returns the height for decorations. Where does it come from? I guess from, you check the font height, and that's basically it. There's something to, basically, I guess you need enough for the title. Renders the given container and its children, meaning that all rects are updated correctly. Note that this function does not call any XCB functions, so the changes are completely done in memory only and side effect free. As soon as you call X push changes, the changes will be updated in X11. So this is using, I guess, an in-memory model of the tree, and then they're going to render all at once. And this is not dissimilar from what we saw in Flutter and React, where like the virtual DOM sort of stuff, I guess. So render con, we've got some parameters, and we check the container type. And if it's a workspace, we calculate effective gaps and inset some rectangles and call rect add and set the con rect to the result of rect add. And then we set some parameters. And then if gaps should inset con, and we maybe do, I guess these are inner gaps probably. We set con mapped to true. I'm not sure what mapped means. Maybe it means that we have an internal memory version of it. And then we're done here. And if this container contains a window, set the coordinates. If we have a window, then depending on the border style, the rect of the child window needs to be smaller. So you have like an inset possibly, and we set the window rect to be equal to the inset, which we get by decreasing the width and height by the border width, by twice the border width, I guess, because you have one on, you have like a border on the left, border on the right. So you've lost 2 times the border width. And then we look for full screen nodes. And I think the container time is output. I'm not sure what an output is container. Well, sorry, what an output container is. But if it is not an output container, then we call a container get full screen con and set full screen to be the result of that. I guess that's maybe checking whether that particular container is taking up the full screen. I'm not sure. And if it is full screen, then we do things like call X raise con. Maybe that, does this focus on the container? Raises the specified container in the internal stack of X windows. The next call will make the change visible to X11. I guess it just raises it in the stack. And we call it render con, which should render it. Actually, this is the same as the function that we were already reading. This seems to be a recursive call. Is that right? All right. And then we find height and width and whatnot and do more stuff. L output. So L output is the layout output. I'm not sure what L output is or C output, but that's fine. Okay. So render, I think, seems more or less to make sense. They're going to render all the tree stuff and then call some push to X11. I guess we should at least look at window. Updates window attributes, X hints and properties. So this is maybe more about the communication layer to X. Window update class updates the WM class consisting of the class and instance for the given window. Window update name, etc. Okay, so this is, I think, not so important. Let's look at workspace. Modifying workspaces, accessing them, moving containers to workspaces. I guess workspace is probably an X11 thing, right? Let's look at get existing workspace by num. We set some stuff to null. We look at the tail queue, and for everything in the tail queue, we call grep first. And we check whether the child num is equal to num, I guess is probably what this is really doing. And maybe this sets the workspace as an output parameter. Maybe you can look at this function. Greps the nodes with the given head, returns the first node that matches the given condition. Okay, and then we return the thing that matched. Apply default orientation, which we get from the config. Get assigned outputs returns the first output that is assigned to a workspace. All right, workspace get returns a pointer to the workspace with the given number. I'm just curious if it calls workspace. So we just get workspace by name, and that gives us basically some pointer. Let's look at this implementation. This is the one basically we just looked at. So somehow, by the time things go into the tail queue thing, they have a workspace. I have a feeling that workspaces are an X11 specific thing, but I'm not positive. Say, are workspaces part of X11? Or are they implemented by the window manager? Primarily implemented by the window manager. Okay. So they're not part of X11. I'm not really sure what makes a thing a workspace. I guess that given the code that we've seen, like any string really would serve it, or number would serve as a workspace identifier. And then when you switch workspace, we just essentially pull all of the Windows stuff with that identifier, possibly from the queue, the tail queue, since that seems to be where a lot of the stuff happens. And we just set that to be what's visible on screen, I guess. I don't see really anything else about workspaces. Any other place that they would be implemented? Move to output. Move the given workspace to the specified output. Is output like a screen? Maybe here? I'm not sure where this output type thing is defined. Get output for cons. This is going to call get output by name. Yeah, so I think that's the sort of thing that's going on. We just have essentially some identifier. Let's see what workspace is visible. What does it do? Returns true if the workspace is currently visible. So we just call get output for the workspace, and if the output is null, there's no output. So I guess output is probably like which screen is it on, which like X output it's on. And if it's null, then it's not visible. Otherwise, we call get full screen con on the output. Okay, so first we look up our record of where the workspace is, and if that's null, we return false. Otherwise, we look at what we think is on the output. And if the thing that we think is on the output is the same as the workspace, then I guess we say that it is visible. And that's about all the time I have. So that was pretty interesting. The heart of i3 is essentially this tree of containers, and it's probably doing more or less the same thing that Emacs is doing, or that Tmux is doing, in terms of splitting things. And it's basically a tree algorithm. And then the hard part of after you hack together all the tree algorithm stuff, so if you were implementing something like this, the hard part would be making sure that as you're talking to X, I think the you aren't doing anything that is incorrect or is disruptive to the screen or is hanging forever. All those sorts of fiddly bits of knowing how to interface with the low level stuff of the the windowing system like Wayland or X. That's going to be kind of the hard, low level, grindy bits. And then once that's all under control, the high level stuff with the containers and the windows is all relatively nice to work with and write algorithms for, which is possibly one of the reasons tiling window managers are, I think, a little easy to reason about for people who use them. They have a logic to them that probably appeals a lot to programmers. That's all for me. Daraz is saying this is very informative. Yeah, thank you for watching. I'm glad you enjoy them. I'm glad you're learning a lot. So